All right, everybody, we're done with chapter 2. So the hard part of this class really is over. Now it gets to be more straightforward and direct. But we have to know all that stuff in chapter 2 to move on because we'll refer to it a lot of times. What we're looking at now is what a derivative is. Ever hear the word derivative? What does a derivative mean to you? What is to derive something? Not a car. Exactly. It builds up from something else. And that's what this is also. Because what we're looking at here, because remember in chapter 2, the whole goal of chapter 2 is what? What do we start off finding? The first thing we talked about was a slope. That was a rate of change. So in rates of change, the first thing we talked about was the average rate of change. What was the formula for that one?
Y2 over minus Y1.
Yeah, it's just a regular old slope formula. This is the slope of the line secant to the curve f of x. What does secant mean in this case? When we say secant to the curve, what does that mean?
One is the one that it touches at 1 point. One is the one that it touches at 2 points.
So which one's which?
And if I could access my textbook, I could just tell you that.
Secant crosses at 2 points. Right, because if you notice, we have x1, we have x1, y1, and x2, y2. This is 0.1 and 0.2. And then we moved on to an instantaneous. Rate of change. What's the formula for that one? Actually, there isn't one because remember, at this stage, we had to find h was the distance between x1 and x2. And we had to keep on making h smaller and smaller and smaller. So what we eventually found that way was we took the limit as x approached 0 of our function, and we found a limit. But as we saw in the homework problems, is we had to first find this secant line, the slope of that line. And then we had to find it for this next one, and then for this next one, and this for this next one. And each time we had a different slope that's approaching the true slope of that curve at that point. Because that's our entire goal, to find out what is the rate of change of a curve at one point. Which is where section 1 of chapter 3 comes in. tangent lines and the derivative at a point. So let's derive the whole thing. What we're looking at here, it all starts with the slope equation. Okay. In algebra, we then learned about functions. We then learned about functions because a function, instead of y, we put f of x. Here we go. Here's the packet for this chapter. I know I should have put it back there, shouldn't I? So now our problem is, because we only want 1 point, we only want the curve at the slope of the curve at 1 point. That means all these other x's have to get closer and closer and closer. So we define that distance as h. So h really is, well, we have x sub 1 plus h equals x sub 2. Why is that important? Well, because now in our function, and I'll rewrite over here. In our function, since we're looking at the slope of a curve at only 1 point, we can only have 1x. So now we have to write x2 as a function of x1, which we did that right here. So instead of x2, x sub 2, we put x sub 1 plus h minus f of x sub 1 over x2 minus x1. Well, remember, we can't have two x's, so we only have one. So how do we rewrite x2 minus x1? Yeah, so if we subtract x1 from both sides, that equals h. Okay, so what do we call that equation?
The difference quotient?
The difference quotient, very good. Because it's difference, because we have a subtraction on top and it's a quotient because it's a fraction. So that is how we can now look at any function given, we can find the slope of that function at any 1 point. Just by looking at this. Now remember, h, what does h represent? H represents the distance between x1 and x2. And we want h to go to 0. So what we have to look at now is the difference quotient the difference quotient at any point we're looking for. So this is the formula we'll be using for this first part. Example 1. A. Find the slope of y equals 1 over x at any point x equals a that doesn't equal 0. A1. What's the slope at x equals -1? Part B. Where does the slope equal -1/4? And what happens to the tangent line as a changes? So those 4 questions that we have to answer. All right. So let's begin. F of x is equal to 1 over x. We're asked to find the slope. How do we do that? Well, to find the slope, remember our formula for a slope? What does this curve look like to begin with? What does 1 over x look like? Right, because as x gets bigger, what happens to the function? As x goes to infinity, what does the y go to? 0. It gets smaller, it gets smaller and smaller and smaller. As x gets smaller, as it gets closer to 0, it gets bigger and bigger and bigger. We just talked about the horizontal and vertical asymptotes. On the negative side, as x gets very, very small, it goes to negative infinity, it gets closer to 0, and as it gets closer to 0, it goes to negative infinity. So it looks like this. That's the graph. What do we notice about this? To begin with, what do we notice about all the slopes of this function? Is it an increasing or decreasing function? Or both? It's always decreasing, correct. So because it's decreasing, what do we know about our slope? The slope will always be negative. So what we have to do is we have to look at the limit as h approaches 0 of our function f of x plus h minus f of x over h. Because that's the only way we can find the slope at one point. But it said when x equals a, do we have an f of x plus h anywhere? No, we have to find an x plus h. What is that going to look like? What is it? Here's the f function. In place of x, what do I put? X plus h. It's whatever's at parentheses. So it's going to be x 1 over x plus h. So once we define those, we can go ahead and plug in both of these unknowns to us. F of x plus h is 1 over x plus h minus 1 over x all over h. But we also know that x equals a, so the limit as h approaches 0 of 1 over a plus h minus 1 over a over h. Now
Professor, we just substituted the a for an x because they're equivalent terms.
right, because there's it told us to, right. Yes. Because our entire question we're looking for is what happens when a changes. So we set a x equal to a and then go from there. Now we go ahead and simplify this equation. So on top, we can combine the two terms. So this first term needs an a over a. The second term needs an a plus h over a plus h to get common denominators. So 1 times a is a minus 1 times a plus h. We can go ahead and fix the top. We distribute that, so we have a minus h. H on the bottom, a plus h. On the very top, the a's cancel, so we have negative h. H approaches 0. Now we have a compound fraction, so what do we do there? It's a fraction over a fraction. Take the top fraction, leave it alone. And flip the bottom, multiply by the reciprocal of the bottom. The h's cancel. So we have the limit as h approaches 0 of -1 over a times a plus h. Then what do we do? Can we do anything else here? What? We simplified as far as we can go. So now we've set h goes to 0. H goes to 0. We're left with -1 over a squared. That is the question answer to the first part. This is the slope when x equals a. All right, so the part B, this is the first part. Part B said, what is the slope at x equals -1? Any guesses?
-1 where a is.
Mhm. Word. So the slope is -1. All right, again, that's just numbers, but what does it mean? What does that number represent? I know it's just easy to find numbers, but what do they mean?
The rate at which it's moving in the function. Rate of change or that's.
Yes and no. Remember the graph.
It's the slope where. Wait, where does the slope be negative?
At -1, answer is -1. This is the slope of the line tangent to the curve at x equals -1. That's the rate of change of the tangent line at that point. But you're right. And what that really means, because remember, when we found the slope, we're finding the line tangent. Slope of the line tangent. So what that relates back to the function is at that point, the slope of the function at that point is -1. So it's negative down 1 over 1. But because this is a consistently decreasing function, what happens if it moves just a little bit to the right? What's the slope there? Is it still -1? Or does it increase? Or does it decrease?
It would increase. It's going to.
You're asking me a question as an answer.
Well, the slope becomes greater. I mean, like, it's gonna go from, if we move that direction, then it goes from like -1 to -2. Now you have to think like the opposite way, is that bigger?
Right.
Sure.
Yes.
Answer the second part.
Because what's happening here, as we move further, the slope of the line it does become, it increases in value. So the slope becomes more steep. Eventually, because it's an asymptote, it approaches infinity. In other words, a vertical line. So if you think about it, it starts off near horizontal. As it goes on, it's increasing in slope, and then it's almost vertical. Then on the other side, it's almost vertical, and then it decreases, but it's still negative. So as x changes, this is part D. As x increases, on the interval the slope increases. As x approaches infinity, on the interval 0 to infinity, the slope decreases in value. It becomes more shallow. Question B asks, where does the slope equal -1/4? Where would I start looking for the answer? What does m equal? What's the formula for m? -1/a². So where does that equal -1/4? No. Anybody agree with that? A equals 2. Okay, so we know the numerators are the same, so we know that a² has to equal 4, correct? Square root both sides. What does a equal? ±2. If you think about it, because the graph is pretty much symmetrical. At -2 here and at +2 here, the two lines are going to be parallel. So those slopes are going to be -1/4. So the positive and negative of each value x is going to give us the same value for the slope because they're going to be parallel at that point. So far, so good? It takes a little bit of thinking, but again, and here's the worst part. We did this in algebra. If you think about it, everything we did this morning is algebra. The only thing calculus C we threw in there was we put the limit in there. Let's go one step further. Let's now define the first part of calculus. The rate of change is the same thing as a derivative at a point. So the slope is the same thing as a derivative. This hash mark means first derivative. And we'll go through all the symbols that we can use for derivatives in a little bit. Now, if you think about it, if this is true, if the first derivative is a slope, how do we just define the slope? We define the slope as the limit as h approaches 0 of our difference quotient. And there's a definition of derivative. As we know it so far. Let f of t equal 16t squared the average rate of change of movement this is that rock we had originally over the interval t equals 1 and t equals 2, or 1 plus h. Where h is always positive. So if we let this function be that, the average rate of change of the movement of a rock over the intervals t1 and t1 plus h can be found by the difference quotient. Well, the limit as h approaches 0. So f of 1 plus h is 16 1 plus h squared minus 16 1 squared all over h. What do we have to do next? If you had to solve this, what would you do next?
problem in the first class, right? So don't you just, I don't know the language, but you. Is it distribute?
You would, but not yet. Order of operations. Can we do anything inside the parentheses? Can we add 1 plus H? No. So what is the next thing? Exponent. So what we have here would be 1 plus H times 1 plus H. This one we can, because 1 squared becomes 1. We have to FOIL these two first. One times 1 is 1. 1 times 8 is a positive H plus H plus H squared minus 16. We can combine like terms, so we have 16, or the limit, as H approaches 0 of 16, 1 plus 2H plus H squared minus 16 over H. Now we can distribute, because we haven't, there's nothing we can do inside the parentheses of the brackets, so now we distribute. Because one of the things about the difference quotient, 16 times 1 is 16. 16 times 2 is 32H plus 16H squared minus 16. Whatever's after the minus sign in the difference quotient has to cancel. So that minus 16, that positive 16 cancel. (32H plus 16H squared over H). We can factor out an H on the numerator. So we have 32 plus 16H over H. The H's cancel. We have 32 plus 16H. H goes to 0. So we're left with 32. 32 feet per second. That's how far it's falling, how fast it's falling. It's a constant rate of change. So far, so good. That's it for that section.
Professor,
Yes.
so if our H approaches 0, that means our slope is 32 feet per second?
Well, when H approaches 0, we're left with this value. This value here, 16, is 16 feet per second.
Yeah,
But since the H goes to 0, it disappears. We're just left to 32. And the only unit we have from unit measurement of falling objects is gravity.
so is this our instantaneous rate of change?
Yes.
Okay,
How do we know it's instantaneous as opposed to average?
our H is 0.
Well, no, because we don't have 2 points, we only have 1 point.
Yeah,
Yeah, and as the difference of the 2 points goes to 0, we only have 1 point, therefore it's the instantaneous rate of change.
okay.
That's the instantaneous rate of change.
Thank you.
So now we learned a faster way of doing this stuff.